Everyone, I'm Varshika from KMC. I'm working on project Legal RAG, which is Retrieval-Augmented Generation. It is designed to make AI more reliable for answering legal questions. It works by combining Retrieval-Augmented Generation with fine-tuned legal models. We added a recursive feedback loop that checks and corrects responses, which helps to reduce hallucination and mistakes. The system also uses hybrid retrievals and audit agents to ensure answers are trustworthy and fact-based. This is important because in legal field, accuracy is critical. By providing grounded responses, our project can support legal professionals and save valuable time and help prevent misinformation in sensitive decision making. Coming to base paper. The key idea of base paper is to combine retrieval augmented generation or RAG with the feedback loops. RAG helps the AI to pull relevant legal information from the trusted sources, while the feedback loops checks and improve the response. Together, this reduces the hallucination and makes the answer more accurate for legal questions. Next, challenges. Even though this system is powerful, there are some challenges. The first challenge is reducing AI hallucination while handling the complexity of legal languages. Another issue is limited availability of high quality legal data sets, which makes training harder. Bias in legal data can also affect fairness. Finally, since law is a sensitive area, expert validation is required, which makes reliable evaluation and adoption more difficult. Coming to problem definition, the core idea of this project is to combine retrieval augmented generation or RAG with fine-tuned language models. On top of this, we add a recursive audit agent loop which helps refine and improve the answer until they are reliable. Next problem to solve. Currently, many legal AI tools suffer from hallucination, meaning they generate information that looks correct but it is actually wrong. They also struggle to properly interrupt complex and ambiguous legal languages, which reduces their trustworthiness. Solution. Our solution is to use hybrid retrieval combining BM25 and DPR methods with fine-tuned legal models. Along with these, we use an audit agent and a feedback loop which checks and refine the answer to ensure accuracy and reliability. Next, expected outcome. The expected outcome is that the system is produce accurate, grounded, and reliable answer to legal queries. Importance. The project is important because it provides trustworthy answers for legal professionals. By reducing the risk of misinformation, it helps ensure the high stakes legal decisions are based on accurate and dependable information. Next, scope of this project. In this project, our scope includes building and testing the legal RAG framework. We will fine tune both the embedding and generative language models with legal datasets. For better accuracy, we will apply hybrid retrieval methods combining BM25 and DPR. Finally, we will evaluate the system's performance using matrices such as high rate, mean reciprocal, and relevance. Next, out of scope. However, there are certain things that are out of scope for this project. We are not focusing on real world development in court or law firm. We will also not delaying the large scale integration with national legal datasets. At this stage, we will not include human expert or legal professional validation. And finally, the advanced features like 3D and real world legal advisory systems are also beyond of our current scope. Now let us look at the architecture diagram. This legal AI system is designed with two main components, the RAG layer and the fine-tuning layer. The RAG layer manages real-time responses by first ingesting a large collection of legal corpora, converting them into vectors and storing them in the vector database. When a user submits a query, the embedding model transforms it into a vector for hybrid search, which retrieves the most relevant legal document chunks. These chunks are refined to a re-ranking process, and the best results are combined with a query to create a prompt for the generative model. The generative LLM then produces an initial response which is reviewed by a content evaluator. If the response is factually correct and legally sound, it becomes the final output. Otherwise, the output uses a feedback loop to refine the answer. Supporting these fine-tuned layer continuously improves the models by training the embedding model with domain-specific legal data to better understand legal semantic and fine-tuning the generative models using methods like PEFT and LoRa on legal question and answers and instruction datasets. This ensures the system not only retrieves the right information but also generate coherent and legal accurate responses, making the entire framework more reliable and trustworthy. Next, conclusion. To summarize our project, this system reduces AI hallucination and ensures the response are legal, rounded, and verifiable. Legal RAG achieves this by combining retrieval-augmented generation with the recursive feedback loops, which helps produce accurate and trustworthy legal answers. Overall, this project can support legal researchers, improve access to justice, and even help in legal education. Next, future plan. Looking ahead, our future plan is to develop a working prototype and test it in real world scenarios. We also plan to expand our legal datasets across different jurisdictions to cover more cases. Another step is to improve our evaluation agent so it can handle more complex legal queries. Finally, we aim to develop user friendly interfaces so that both professionals and non experts can also use easily this system.